The Earth's rotational axis, or how the Earth spins around with the passing of each day, is tilted slightly. This causes the season changes, as the tilt in the axis points the Earth toward or away from the Sun as it travels around in its yearly revolution. If the surface area that's being flooded by light is tilted, the strength of the light and the reach of its rays will be altered. That area that is tilted furthest from the source will receive the least amount of light, and that which is closest will receive the most light. Okay, now that we have all of our supplies, everything we're going to need to conduct our experiment, we want to start by creating a light source. So you're going to need your cardboard box, and for this we're going to use a regular cardboard tube, paper towel roll, toilet paper roll. I'm going to tape it down really quick, just so that it doesn't move and stays in place. Okay, this will just give us a little tighter of a beam of light. Okay, and then I take my flashlight, and I'm just going to put it right there at the edge. Grab another piece of tape and tape that down so that doesn't move. Okay, and there's our sun or light source is all set. Next, you want to get your piece of graph paper ready. So, I'm going to grab a clipboard and a piece of graph paper. And you can put a little piece of tape on the bottom just to keep everything from moving around. Okay, first thing you want to do is you want to put that right in front of your light source so we get this nice circle here. And you can move that forward or back until you have a circle that's about 5 to 6 centimeters in diameter. Here we're a little off, so I'm just going to scooch it up. Okay, and there we are. And you want to take a measurement really quick to see, holding the clipboard straight up, how far away your clipboard is from your box, just so you have a reference point, because you want it to always be that far away. So I have it at about 1 inch and a quarter. Just want to write that down really quick. 1 1/4 inch. Okay, now using a protractor, you want to just put that right on the edge of your clipboard, so you make sure that your clipboard is standing directly straight up with a 0-degree tilt, or at the 90-degree mark. Holding that at the 90-degree mark, grab your first colored pencil, and you want to just trace the line around the light circle. Okay. Also take into account what the circle looks like. Since it's our first circle, we know that it's very tight, it's very clear, so you're just going to write that down. On our chart here, going to be collecting our data here on our chart. And after completing all 5 of our different tilts, we have 5 different circles, and we've taken notes about how the light has changed throughout that. So now we're going to repeat this process 2 more times, so you have a total of 3 different trials so you can obtain an average. Now that we've done all 3 of our trials and we've completed our 3 graphs, graph number 1, graph number 2, and the third one, you can then take this information and you can use it to fill in your chart. Same thing as before, your observations, then counting how many squares are in each one of the circles. We can then take this information, input it into a graph, and begin to analyze our data to come up with a conclusion. It is apparent from the table and graphs that the surface area receiving light changes as the tilt increases. The tables show an increased surface area, but analysis of the observation notes concludes that while the area was becoming larger, the light at the uppermost part of the circle was dimming as it grew in size. The lower part was becoming more intense and saturated with light. This corresponds to the change in the seasons. As the northern hemisphere tilts away from the sun, receiving less light, it results in cooler temperatures. At the same time, the southern hemisphere is tilted toward the sun and receives more intense sunlight, resulting in warmer weather.